Hey guys, it's me. Today I did question 1018 binary prefix divisible by 5. So let's explain what this question is asking. So let's say you are given an array of binary numbers and you're trying to find if each prefix is divisible by 5. So let's take this example 101. So what this is asking is you're gonna go look through every prefix. So first prefix is gonna be 1, and 2 to the power of 0 is gonna be 1. And is 1 divisible by 5? No, it's not. So it's gonna be false. And next, you're gonna check the next prefix, 10, and you're gonna read the binary left to right. So this is gonna be 2 to the power of 0 and 2 to the power of 1, which is gonna be 4, which is gonna be 2, I mean. And since 2 isn't divisible by 5, it's going to return false again. So next, you're going to move to this prefix. This prefix is going to be 0, 2 to the power of 0, 2 to the power of 1, and 2 to the power of 2, which is 4 plus 1 equals 5, and 5 is divisible by 5. So the answer would be false, false, true. So unfortunately, I was not able to solve it by myself because there was a cool math trick that you have to sort of know, which I didn't know, so I just searched up the answer. But let's explain the code. So the code, you first need a malloc array, so I just made an array with size that's given. So for this solution, the math trick is that when you're shifting or going through the prefix, let's write this. When you're going through the prefix, you're multiplying the sum or you're multiplying the number by 2 each time. So for example, let's say you want to get this number. What the trick is, you would do 0 times 2, because that's the initial, plus the current binary number, which is 0. So then you get 0. That would be 0. That's how you read this one. And then to read this thing, it would be 0, which is the previous one, times 2, plus the digit, which is binary digit, which is 1. So then this, you would get 1. And then you would do the previous, which is 0, which is 1 that we got. So then it would be 1 times 2 plus 0, which we would get 3. Or 2, I mean. And it works because it shifts the binary number to the left, and every time you shift it in binary, you would times that by 2. So right here, it's 2 to the power of 0, and then 2 to the power of 1. So then 2 to the power of 2, you're just multiplying by 2 each time. So let's go over a test case. Let's trace the code using this test case. So the first prefix we'll look at is going to be 1. So the sum is going to be 0 times, sum is equal to 0 times 2, plus the binary digit, which is 1. So then we would get 1 for this, and 1 is not divisible by 5, so we do false. And next, we switch to the next prefix. And since we're shifting to the next prefix, the previous was a 1, so then you do 2 times 1, and then plus the current binary, which is 0. So then we get 2, and it is true because when you read it left to right, it's 2 to the power of 1 plus 0. So then it would just be 2, which is also invalid. It's true false. And then we go to the next prefix. It's going to be 2 times 2 plus the binary digit 1. And then if it's going to equal 5, and it is divisible, so then we get true. And let's move on to the next prefix, and I think you probably get what's happening. So then we have 5 times 2, which is 10, and then plus the I, or 1, or plus the binary 1, so it's going to be 11, and this is going to evaluate to false. Now we do 11 times 2, 22, and then plus the binary 0, which is also going to be false. And if we run it, or add the test case, I should be correct. False, false, true, false, false. Yep. And that's how the code works. It was actually kind of hard if you don't know the trick.